A block of mass 17 kilograms is at rest on an incline of 25 degrees. Also, a 21 Newton force is pulling on the mass down the ramp, and an 82 Newton force is pressing the mass into the surface. Find the normal force and the friction force on the mass. So here's our situation. You can see we've got a force down the ramp and a force pressing mass into surface. That's what that stands for. And we want to know what the normal force is and what the friction force is. Let's draw a free body diagram with numbers. There's our 17 kilogram mass. There's our 82 Newton force pressing the mass into the surface. There's our 21 Newton force pulling on the mass down the ramp. We're going to take the weight, which is m times g, and we're going to break it into a perpendicular component and a parallel to the surface component. Now, this vector mg right here would be equal to 17 times 9.81, m times g. Well, what we need to do here is we need to take m times g, and then this little angle right there is numerically the same as this angle in the upper right, so that's 25 degrees. So, in short, this component will be found by taking mg cosine 25, and this one will be found by taking mg sine 25. So you check and make sure that when you take 17 times 9.81 times the cosine of 25, you get 151.1. And when you take 17 times 9.81 times the sine of 25, you get 70.5. There's also a normal force that's acting on this mass and a static friction force. So let's write the Newton's second law equations. We always start with the perpendicular direction. If I choose the normal force to be positive, then the 82 Newton force will be negative, as will the 151.1. And that should equal the mass of the object times the acceleration perpendicular to the surface. This mass is at rest, which means the right side reduces to 0. We can calculate the normal force to be 230 newtons. Now let's write a Newton's second law equation for the other direction. If I choose down the plane to be positive, that will be 70.5 positive plus 21 positive minus the static friction force, and the sum of those forces should equal the mass of the object times the acceleration parallel to the surface. Again, this mass is at rest, which means we can solve for static friction to be 92 newtons. In this problem, we have a 52 Newton force that acts downward along a 41 degree inclined plane on a 22 kilogram mass. The force is parallel to the plane, the coefficient of kinetic friction is 0.49, and the mass is already moving. Find the acceleration of the mass. We have a mass that is sliding down this surface. It's already moving. We have a force that's pushing it parallel to the surface, and we want to know what the acceleration of this mass is. So let's draw a free body diagram. There's our 22 kilogram mass. There's our 52 Newton force. Any mass, of course, has a weight equal to m times g. So if I were to draw an m times g vector on this free body diagram, it would extend from here to there, and it would have a magnitude of m, 22, times g, 9.81. In between that mg vector and this perpendicular component right here, this angle that I'm trying to sweep out with my laser pointer, that angle right there is equal to the angle of the incline, which is 41 degrees. In short, what we can do here is we can find that the perpendicular to the surface component of weight is going to be mg times the cosine of theta, and the parallel portion will be mg sine Well, what other forces do we have? Well, we've got a normal force, and we've got a kinetic friction force. We know it's kinetic friction because this mass is moving, and kinetic friction is always equal to mu sub k times the normal force. So now, let's jump to Newton's second law. Let's sum the forces perpendicular to the surface. If I choose the normal force to be pointing in the positive direction, then this 162.9 is pointing in the negative direction, and that should equal the mass of the object times the acceleration perpendicular to the surface. The acceleration perpendicular to the surface is 0, which allows us to find the normal force to be 162.9 newtons. Now let's sum the forces parallel to the surface. Since this mass is moving down the plane, I like to choose that way to be positive. This 141.6 newtons is pointing positive. The 52 newtons is pointing positive, but friction, which is equal to mu sub k, which is given, times the normal force, which we just calculated in the previous step, that is pointing in the opposite direction, or negative direction, which is why there's a negative sign right there. And the sum of those forces by Newton's second law should equal the mass of the object times the acceleration parallel to the surface. You should be able to solve that equation for the acceleration. The left side turns out to be just some number, 113.8. Then we can divide both sides by 22, and we get an acceleration of 5.2 meters per second squared.